All right. Thanks very much for joining us today, and welcome to our webinar, Enhancing Resiliency, Assessing and Adapting to a Changing Climate. So here's our agenda today. My name's Alyssa, and I'll be giving a quick introduction to Partners in Project Green, and then we have Edmundo Fausto joining us from the Ontario Climate Consortium. And then afterwards, we'll have a brief question and answer period. So if you have any questions or if you're having issues with your audio, please feel free to type in the chat section to myself, TRCA admin, and we'll get that sorted out and we'll get your questions answered at the end of the session. So I'm with Partners in Project Green, and basically our main mission is to create the Pearson Eco-Business Zone, which will be an internationally recognized community known for its competitive, high-performance, and eco-friendly business climate. We cover 3 municipalities, including Mississauga, Brampton, and Toronto. Our main study area has over 14,000 hectares, over 12,000 businesses, and over 350,000 employees. However, we have had a number of successful projects across the Greater Toronto area. Our major sectors include manufacturing, food processing, hospitality, and aviation. These are just some of the members that have joined us this year. I believe as of the count of this week, we have about 64 members in our official membership, and that number is of course growing. So feel free to reach out to us if you have any questions about membership. So as far as the water stewardship group itself, so these are some of our 2015 results and some of our programs that we have. So today's webinar, you joined us a little bit to learn about climate change. And one of the ways you can kind of mitigate your risks and your operations is through participating in sustainability programming that allows you to reduce your dependence on municipal water supply, municipal energy supplies, and utilities in general. So we have a water auditing program that identifies efficiency and retrofit opportunities, as well as helps your business apply and qualify for various municipalities' incentive programs. And then we also have a stormwater infrastructure project, which helps you mitigate on-site flood risks through installing stormwater management best management practices. And additionally, through working with Partners in Project Green, you have access to vendor discounts and support. And the stormwater infrastructure projects helps you and your business mitigate the chance and risks of floods on-site on your properties. Some quick 2015 results. We were able to save about 212 million liters a year in water footprint offsets through direct results from the programs I just mentioned, as well as our indirect results through various partners and members that I had listed before. We also established a vendor network that I just mentioned, as well as had over 475 attendees for some of our water-related events, one of which you're attending right now. And we also had 5 feature articles and 4 panel speaking engagements as well. So without further ado, I'd like to introduce Edmundo. So Edmundo is the project manager for the Ontario Climate Consortium and will speak to us today about climate change and resiliency. Over to you, Edmundo. I believe I unmuted you.
Thank you very much.
Yeah.
Yes, perfect. So thank you very much, Elisa. I think everybody can see my slides now. Like you introduced me, thank you very much. I'm a project manager for the Ontario Climate Consortium. And today we're looking at talking about climate change. We're going to do a bit of a sweep through what is it, what does it mean. I won't go too far into the basics, but ideally it should help set up the conversation towards what does it mean to enhance resiliency and how do you go at least in broad terms, how do you go about doing that? So as Elisa said, I'll give a little bit of information about what the OCC means, or the Ontario Climate Consortium. We were established in 2011 as a center of expertise to provide research and analysis services to municipalities, conservation authorities, and overall the broader public sector. In brief, we aim to deliver high-quality advice to Ontario's public and private sector to support them in their development of implementation of climate change, both mitigation and adaptation work. We coordinate research, we coordinate analysis, and often participate in interpretation with other expert groups to stimulate innovative thinking and implementation of projects. We also facilitate knowledge exchange to make sure that things are being kept effective, and this accelerates the steps towards policy and actions, and always keeping in mind that the process should be evidence-based. So our goals as a program is to support the implementation of climate change response at the local and regional level in Ontario, and we aim to do this by facilitating knowledge exchange between the Ontario Climate Network of research experts, the public, and the private sector decision makers. Our main areas are usually climate information and analysis. We do climate adaptation at different levels, and we do climate mitigation planning. We're obviously a consortium, so we have a collaborative model that includes 440 municipalities as well as different conservation authorities across the Greater Toronto and Hamilton area, as well as various public sector agencies that have become involved at various levels with the Ontario Climate Consortium. So what does that mean to somebody in the public sector? It may mean that we're able to facilitate or participate in creating customized research through our partnerships, in facilitating and guiding risk and vulnerability analysis, in producing standardized guidance, again, usually in a collaborative framework, and as well as to guide resiliency action and implementation of plans. More importantly, also, we have a lot of efforts put towards communication and dissemination of knowledge and the work that is being conducted in the area in Ontario as well. So first of all, we're going to talk a little bit about what is something that is relatively basic, but I think it's always good to touch on, which is weather versus climate. Like, what is the difference? And somebody posed this brief story to me, and I thought it very well exemplified the differences, at least at a high level, of what is the definition of weather versus climate without getting into terms. So imagine that I'm going on a beach with one of the dogs that I have, and as you walk along, you actually see your footpaths or my footpaths going from one side of the beach to another. Usually there would be in a pretty straight line, and relatively they're just going in one direction as the time goes by. However, my dog on the leash is probably going up and down the beach uncontrollably and back and forth quite unpredictably, and within a range of right beside me to about a few meters away from me. So what this draws the conclusion is that climate is pretty much my steps. So it's the person holding the leash, or at least a trend that you would see in both things moving forward, while weather could vary at a quite wider range, either in a positive way or in a negative way. So this comes to talk about the fact that even though, for example, this past year we have quite a warm winter, this may not mean necessarily that climate change is not happening or climate variability is not taking place. Often climate variability and climate change take place both at the same time, but overall this is kind of how you can differentiate it one from the other. So in order to be able to talk about climate, obviously we need to create information and data in order to be able to see how things change. So this data and these different methods to track the weather, which ultimately give us a little bit of information about climate, right? We're tracking the dog to find out where the person holding the leash may be. This all gets involved into and has been adopted by many different organizations, and it's involved in everything, pretty much everything we do, from infrastructure design through IDF curves, which are developed by Environment Canada, just to kind of try to represent the amount of rain that could be expected to affect a particular piece of infrastructure in its given lifetime, to, for example, the operations of a tenant building, where you're looking at cooling degree days or heating degree days, as well as humidity, to figure out the timing of your chiller coming on or your cooling services, or as well as your heating services, etc. So all this information is available in many different ways. So a more formal definition is usually their observations, models, or synthetically created data that that could be either at a station or in a gridded product, so at a larger scale. Usually these are available in either data points or trends, or in terms of variability, or other statistics that kind of help people understand what is going on, and it depends what you're trying to do with that information. Metadata and contextual information is always required, and helps interpret where the data came from, and in what way was it measured, etc. So all these are parts of climate information itself. So having that in mind, then why do we need climate change information or future climate information? This information always helps us understand the hazards that may be coming or that may be taking place while we work with design or planning of either infrastructure, operations, and this could be from a corporation point of view or from a municipality or even at a country scale, right? Understanding what has been happening and what may happen based on how the future may play out, it's obviously helpful for many reasons. And a way that this gets incorporated in many different scales is through the climate adaptation cycle, which involves using the climate change science, using data and information available, and making sense of that in order to integrate it within a cycle that includes some planning efforts, as well as some implementation, some verification, monitoring, and adjustment of the plan in order to reduce vulnerabilities or just mitigate exposures. So this type of data can be available. We usually catalog it in two ways. We either have historical information, which is usually, many of you are probably familiar with, for example, Environment Canada or the Weather Network. They have, so what happened yesterday, what happened the day before, you can get access, and what happened 2 years ago, you can get access to this information and kind of get an idea of what the weather has been in a certain area for the recent historical period, usually going as far as maybe 150 years. That's kind of usually pushing it. But the future climate projections, those obviously we cannot pinpoint exactly what they are, but there's models that help us look at what has happened in the past and then try to predict what may happen in the future. This also, as these exercises get funded and create data sets, they have been made available to the public and to other institutions via web portals or different tools that try to address and bring together the data and pre-analyze it in a certain way that may be useful for a particular stakeholder. So this data can be found in all sorts of formats and all sorts of ways, but both types of data basically could be analyzed in different ways depending on the intended purpose of the results. So a method of analyzing the data or looking at the data in a certain way may be helpful for your neighbor, but it may not be so helpful for you if you're looking to do something different. So having a good understanding of what you're trying to do before you go into gathering data and trying to analyze it is usually a good step in order to mitigate time wasted basically looking at numbers and looking for trends that may not be relevant to what you're trying to do. So whenever we look at projections and try to predict to some extent what could happen in the future, we have different tools. These have been basically usually reported more popularly through the IPCC, the Intergovernmental Panel on Climate Change, and they report usually on the on the global climate models, which is the furthest to your left. These have their coarse resolution models that try to help capture the physics behind climate happening at a global scale. They try to capture things like El Nino and how that may affect central Canada and things like that. Then we have other efforts going on. For those, we have, for the global climate models, we have about 20 climate modeling centers creating and creating different iterations of and recipes of these climate models to try to understand the future in the best way possible. Then from there we have efforts to try to regionalize this climate information and try to capture some of the more regional scale and important features to try to understand what is it going to, how is this big picture going to affect my particular location. And those are called the regional climate models for the most part. And those intend to increase the resolution of the global climate models or through different methods that we won't go far into. One thing to keep in mind is that each of these exercises obviously usually picks a multiple set of scenarios, which are emission scenarios or concentration pathways. These range, the names are usually called RCPs, 6, 4.5, 2.6, and 8.5, going from best case scenario to worst case scenario in the sense of how many emissions are going to the atmosphere and how much energy is being captured within the Earth. So we have multiple iterations about it. By the time you get to the numbers of 20 climate models, 4 different scenarios each, plus the regional climate models, we have a lot of data available and a lot of information out there. So it's key to understand from your location which data is relevant, which data can be useful, and which data can you use for your intended purpose. So just to kind of go over those scenarios to get an understanding of what they're talking about. This is a graph kind of trying to show them, don't get too caught up on all the different lines. It's just showing the different model runs. So all the little black dots are kind of historical information, days that have passed and information that we know where we're at, and because there has been measurement efforts. Then from there, we're trying to project the future. And to project the future, we have one scenario, which is the 8.5, which looks at greenhouse gases and their effects rise for the next decades, creating a greater impact on temperature and precipitation and climate dynamics. We have continues to increase slowly, but then decreases. So this is assuming that we had some mitigation efforts, and we're starting to be more efficient and polluting less to the air. The other one is soon stabilizes and decreases. Keep in mind that these are both taking into account both the greenhouse gas as well as population and other factors of that type. But overall, basically, is we took action, or we are taking action, and by the 2080s, we're significantly reduced. We have significantly reduced, and we've basically decreased the greenhouse gases in the air. And the best case scenario, I guess, is we immediately stabilize it and start decreasing the greenhouse gas emissions in the Earth. So bringing this back to our province and our region, I'll give a few examples of what the projections say for our areas. So at a course level, we are anticipating that heavy precipitation days are going to increase in Ontario. Obviously, from this graph, we can see that it can range depending on your location within Ontario and even within neighboring locations. However, overall, we are seeing an increase in heavy precipitation. By the 2090s, which is about a little bit under a century from now, we're looking at a mean temperature, which is an average daily temperature increase of about 4.8 degrees Celsius for Ontario. This is again at a coarse scale, but still quite alarming. So just to paint a picture, what does that mean? We're talking, for example, for the region of Peel, which is within the Greater Toronto Area, that by the 2020s, our temperatures, not necessarily our precipitation, but our temperatures will feel or look more like what Ohio is currently, and by 2050s, it will be more like Kentucky. So that gives you a little bit something to picture. So these analyses usually incorporate different like I said, different types of numbers. We can look at average temperatures, seasonal, as well as threshold-based values. So whenever we dive into Peel's threshold-based information, which is, for example, number of days with temperature above 30 degrees Celsius, we're looking that there may be an increase of about 14 days in a year. This is obviously just an estimate, but it's still like we can see the trends and where they're going and perhaps what we should be preparing for. We also see that precipitation falling within 1 day is looking to increase, as well as precipitation looking to falling within a 5-day period. It has an increased temperature. Most of the thresholds and the variables that we're looking at in here in this plot, as you can see on the furthest right side, are looking to increase. Usually, it's only the minimum temperature in the day that is actually seeing to have less occurrences, which means that we're going to have less cold temperatures. However, the polar vortex kind of conversation still has to go into this, and it plays a different role on how that will play out. So again, we're getting a little bit into weather variables versus long-term climate. So one thing that we do understand is that there will be impacts associated with changing the climate from the Greater Toronto Area from being the Greater Toronto Area to being Kentucky or Ohio. And that we should kind of understand well what that means, and as well as not just from a general trends of temperature, but also like what is that going to do to those extreme events like thunderstorms, flooding events, winter storms, etc. So this probably goes a little bit to, I want to explain a little bit about the uncertainty, because this is a piece that always gets mentioned, but often there is some oversight through it, which is that within each impact or with each area that we analyze, there is different levels of certainty. The uncertainty is not like, it's not the same across the board. We have, for example, we're more certain that there will be warmer winters, more heat waves, longer growing seasons, and perhaps a little bit less certain or working on the understanding of how increased in wind extremes as well as more ice storms will come to be. That doesn't mean that we don't have an estimate or we don't have an understanding of it. It's just the level of certainty that exists in comparison to the other values that are more understood. So just to bring it back to reality, I guess, and to the past, to things that we have seen in the recent past, the Parliament Budgetary Office actually released a report recently where they looked at all across Canada that there has been, and they accounted for about 118 major climate events in Canada for that period of time. And these were broken down in 77 floods, 31 convective storms, which are usually summer storms, 6 hurricane tropical storms, 4 winter storms. Within all these different definitions of climate events, the focus both, I think, in a Canada range as well as, for the most part, in a Canadian scale, as well as in the Greater Toronto Area, the focus is on intense rainfall causing flooding, because it has a lot of different impacts linked to erosion thresholds, which are being aggravated. Flooding has been also the most expensive weather impact in Canada to date, and many urban areas are particularly vulnerable to this issue. Something that doesn't help the case is also that projections are predicting that it will become more intense for the most part. So the catastrophic insurance losses bureau from the Insurance Bureau of Canada looked at how has their budget been affected by the catastrophic insurance losses. And in this plot, we can see that in 1986, they had a surge of cost which was associated with Quebec flooding. By 1998, they had another surge from eastern ice storms. By 2005, they had the Ontario wind and rain events that took place, and on 2013, they went over $3 billion, almost up to $3.5 billion of catastrophic insurance losses based on both the flood in Calgary and in Toronto. So in the long term, trying to understand, so that is on the insurance side, but what happens with the other piece that some of you may hear about, which is the municipal side or the federal government side. So the same bureau, the Parliamentary Bureau of office looked into the Disaster Financial Assistance Program, which has usually a budget. It was founded in the 1970s to reimburse the province and some individuals via the province for expenses and damages which were coming from disasters, natural or man-made events. The expenses usually come to the provinces. The provinces then, with a set of rules, the provinces adopt the rules or create other rules within those federal rules, and then they disseminate the funds when needed to the different individuals within the province. One thing to keep note is that the DFA does not cover expenses where insurance coverage for a specific hazard is available at a reasonable cost. So whenever they looked at their costs and their liabilities since 2009, they've seen that actually they've been above budget consistently for quite a while, and that especially there is a clear trend of rise in the expenses, in the liabilities. This doesn't take into account for how long it takes them to disburse those funds. But even then, sometimes it can take them up to 7 years. But that just goes to talk to the rate of disbursement and just a delayed effect on the economy. What we're looking at also is that, so whenever we dig into the numbers of liabilities that the DFA has, we're looking at about 75% of that is due to floods. The second one being winter storms. Usually that's, like, again, it didn't come to, I think, as a major surprise to most people reading the report, but it just goes to reiterate the fact that this is one of the main concerns Canada-wide. Whenever we look at the cumulative losses for both the DFA and the insurance and try to compare and see which percentage was covered by who and what was the total loss, we're looking here at the different climate events that were analyzed in the report, looking at floods, looking at convective storms, hurricanes, and winter storms. And we're seeing it's pretty obvious where the DFA had to step in and help because of the lack of an insurance product to help, or the lack of an insurance product at a reasonable cost for individuals and small businesses to use parts. So this, for example, in the flooding piece, the 27.71%, usually it's anticipated to be a little bit high because this was disbursements that were given before the language for the insurance was changed recently to not cover overland flow. So overall, what does the response look like to this type of problem that is affecting both the climate and it's getting embedded into our economy and our day-to-day expenses and perhaps threatening the continuity of business in some periods of time? So one way that we can look at it is understanding vulnerability. And if you can understand vulnerability, you can characterize risk, and therefore you can affect the vulnerability by increasing resiliency. How you can affect resiliency is usually by lowering your vulnerability, which is defined as the attributes of the system or asset that make it more or less vulnerable to climate events, or this could be also including climate change. So by building resiliency, it could be through improving its physical condition, or by partnering and creating protocols that include institutions and governing bodies, or just by the way that people are influencing the system. Overall, it is estimated that $1 invested in anticipatory measures can save you up to $7 in future relief costs. So it's a good idea. It seems to be a good idea in a measured way to get ahead of the problems that could come. So governments and municipalities are undergoing efforts and taking on different projects to try to get ahead of this issue, or try to understand it better at the very least. These include risk and vulnerability assessments of different systems, usually in public infrastructure or public services. They're also looking at standardized health alerts, but particularly here in Ontario, updates on public health standards, sustainability development initiatives, for example, LID, floodplain updates to kind of prevent and mitigate people going into risky areas, monitoring programs, as well as the adaptation and mitigation inclusive sustainability master plan. So they're trying to find a way to kind of embed these concepts and these measures in a way that makes sense within their operations and within their plans. So the question ultimately that everybody's looking for is how vulnerable am I in particular? So in order to get to that answer, usually the process involves considering different climate events like ice storms, extreme rainfall, extreme heat, tornadoes, and other high wind events, just to mention a few, and going through a process to try to get to a reporting and recommendations phase where you can actually you feel like you have a decent understanding of your system and how it may behave in different conditions, and what you could, then you can start talking about what you could do to improve its resiliency. So how do you evaluate? How do you get there? There's different methods and there's different approaches towards a climate adaptation cycle. And to qualify vulnerability, there's a variety of methods that have been put forward and protocols that are used in different scales. So for example, ECLI, local governments for sustainability, so it has its framework. There are some other custom frameworks that have been adapted for different intentions and purposes, as well as Engineers Canada has a framework for Public Infrastructure Engineer and Vulnerability Committee, so the PIVC framework, which has been used for both public infrastructure, as in like owned by the municipality or other organizations that interact with the government. Ultimately, the OCC eventually went through a literature review, which was recently finalized. And to keep it simple, we kind of saw that we're not trying to create another framework, but to keep it simple and give an understanding, we saw that there was 4 main steps in every process that is out there, which included scoping of the assessment, setup of the assessment, analyzing the risk, and then treating the risk. This is an oversimplification of all the processes, but it goes to talk that there doesn't seem to be a silver bullet, but instead there has to be some thought about what process may get you to the final outcome that you're hoping for. So what does going through a process like that do for you as a small and large business or corporation? It actually helps you, like creating an adaptation strategy or creating adaptation implementations can support you in providing the investors and your stakeholders certainty that you're actually well prepared, and you're probably going to be better prepared than others to mitigate climate-related risks. And this could be from various sources, and we have a couple lessons learned that we can talk about. Overall, there is support and there is work being conducted even at the provincial level. Recently, we had the Ontario Climate Change Strategy, which highlighted that adaptation and risk awareness was going to be a portion of their upcoming strategy in later 2016. They're looking at embedding climate change and making climate change adaptation more understandable and more streamlined through making tools in the sense of creating climate information that is more available to different areas. However, a lot of this data is currently available. The challenge currently is to find groups that truly understand it and scope in a way that you're set up towards analyzing your risks and then treating your risks. So whenever we look at, we've had multiple climate events and multiple lessons to learn, but I think one of the very interesting case studies that we can look at to see what happens whenever a big event that comes to a city or to a location that the location is maybe not necessarily so prepared to deal with, and what can we learn from that? So an example that I picked was the Hurricane Sandy, where about 30% of the small businesses affected completely failed, partially due to this event. And actually, I would say that that it was mentioned that it was mostly due to this event. And what this tells us, there is a couple of set of lessons learned that I found very interesting, which was that it's important to plan for different impacts, both in magnitude and duration. So how long and how hard are we going to get hit, or could we get hit? And that crisis management, business continuity, disaster recovery plans, they should all be detailed in a strategy as part of your corporation or part of your business plan. And in order to try to mitigate the downtime that you may have when some of these events have. And also part of that would be to understand well your business's sensitivity to something like this coming on. So another piece that is interesting and is a little bit facing a little bit more externally was understanding your vendor's disaster recovery plans. This could be as simple as, and I'm oversimplifying it, but if you're selling, you're a little shop that sells strawberries and all of a sudden climate changes and you have no strawberries that season, what can you do to actually survive? Are you going to be able to ship it in? Does your vendor have any recovery plans, or are you going to have to switch to sell raspberries or something else that is growing that season? And how do you go about doing something like that, and or at least think in advance to some extent? What could you do in order to whenever things of that sort happen, or if they happen, then that way you're well prepared and well positioned to not have it, to have business continuity and have small effects towards your bottom line. So another important thing is to test your plans. It's great to create plans, but we also have to test them to some extent and have alternative data center recoveries and communications to have backup of the key elements of your business. Another example of whenever we move towards action, I think an interesting example has been New York City with a recent program, a competition called RISE. In this program, they looked at different adaptation technologies, and they actually chose 11 different organizations that they're actually going to move forward and implement these technologies that go from adaptation to adaptation and mitigation. So they go from like things like flood walls for businesses that are known to be inside floodplains and very highly likely to be flooded or have to experience or deal with high water levels, to adaptation and mitigation measures like energy solutions. One example was a business that had solar panels and a cogen using storage capacity to both fit into a grid as well as so whenever not needed to generate electricity, but when required to be able to be functional and reduce downtime in an event that comes to place. And these are large technologies. Some of them are a lot more subtle and of less cost. But overall, they're looking at a 30 million budget to implement this at different businesses that are at risk and highly vulnerable. So corporations are also looking at the corporate level to create action on adaptation. For example, AGVAR look at a research partnership to contribute to the knowledge base and to further understand urban flooding in the context of water management, water resource management. The Banco de Brasil looked at supporting pilot projects of sustainability agriculture, water management, and forestry towards helping the adaptation and sustainability and developing sustainability practices within their area. Coca-Cola looked at a plan level assessment and created planning tools for sustainability watershed management and local partnerships that were required to shared water stewardship, as water was a large part of their business. ESCOM in South Africa, an electricity corporation, they developed an internal climate change adaptation policy, which included external policy engagements and an adaptation at both national and international levels. So they wanted to understand, well, what could they do, what could they interact with others based on their impacts, which is something very interesting, right? Sometimes the impact could be on something that it will affect you, but you may not have the means to act on it before it takes place. So having externals in your committee as you move forward with an adaptation plan, it's definitely helpful to bring a broader picture and create a more realistic sense on your vulnerabilities and what you could increase your resiliency on. There is other measures, adaptation measures, looking at increasing efficiencies as well as increasing data availability that is relevant towards understanding how different adaptation measures are being implemented or what their uptake is like. So overall, from the adaptation recommendations and to manage this risk, you're looking at usually flexible solutions with multiple benefits. Those are usually seems to be, in most cases, the best bang for your buck. And it includes, for example, the low impact development measures for some businesses. I know PPG has several case studies as well as a program called SNAP within the TRCA. But as well, like one of the examples before where they combine both mitigation efforts, so trying to reduce your energy consumption while creating some resiliency with your business, right? So for example, the implementation of LEDs may help you take some energy load off of your generator or so off of your plant in order to allow for your generator to actually be able to support your operations for longer in the case of a power outage. And there is many other features that could be looked at whenever you're thinking of both mitigating your consumption and your effects on the environment while trying to adapt and increasing your resiliency as well as to decreasing your downtime in the case of any kind of event. Thank you very much. I just want to invite you all to our annual symposium if you want to learn more about what we're doing, how we're getting involved, and if you would like to get involved. In the future, we're looking at this climate symposium, which is our 4th annual symposium. It's on May 5th, 2016 at University of Guelph. The link is on the website. We're looking at focusing on climate resilient food systems in the Golden Horseshoe region. We'll be having some work streams which are proposed so far, and we're working on finalizing the agenda. We'll have some of the work streams include bioeconomy, on-farm mitigation, adaptation, and moving towards regional food sovereignty. Thank you very much. I'll pass the controls over back to you, Alyssa.
Perfect. I can do that, I think. Yeah.
Oh, there we go.
Oh, perfect.
Okay, excellent.
Okay, so I guess just a couple of we both, in case people have to leave early, I just wanted to also flash some of the events that we have coming up as well. And the OCC event is coming up and listed on our site as well. So that's partnersinprojectgreen.com/events. And this is our contact information. And in case you have to sign off early, thank you very much for joining us. But we'll be taking this time to answer questions. So thanks very much.